There are a lot of, technologies evolved day to day. We are using all the resources and we are not planned for the future generations. Because by using our present resources, if we go on using the resources continuously, definitely there is a time where all resources are exhausted, right? So if it is, if it is happen, then our future generations are into problem. So Government of India is initiating, you should grow with respect to technology, with respect to products, but we have to think about future generations. That is what sustainable development. Development should happen, but it should happen with a sustainability. Sustainability means what? The resources should be available for the upcoming generation. For what? For that, we have to focus on how to manage the resources. If in the society now we have waste, lot of waste is there. There are different types of waste, e-waste, medical waste, dry waste, wet waste, like that there are a lot of waste. If you doesn't plan the waste management properly, without a strategy, without a technology, definitely that will kill the entire globe. Killing is there. So because of that filling of the entire earth with waste, plastic waste, e-waste and all, then what happens? Climate gets changed. Environment gets disturbed. Economy gets disturbed. Social elements are get disturbed. This is the problem statement. Further problem statement, the solution is circular way of handling the data. What do you mean circular means? There are 4 R's. So generally we will take natural resources, we will take we can make, for example, take this mic. How it is happened because in the carbon, they are developed this. So carbon is an element that we are going to use extensively. We are using. After some time, maybe there is no carbon in the earth. Then how the future generation will use this type of element? That is a question mark. For that solution is, we can reuse. Don't throw out, don't dispose out. We can use it for further use. Reuse it, recycle it, recover it. Dispose is how to recover it for other use. Like cyclically, every product we have to use and recycle. From that, we can create another product. Again, from that, we can create another product. But don't throw out, don't dispose out. This is what happens. Our taking of natural resources will be get reduced. So reduce, recover, reuse, and recycle. These are the 4 steps we have to follow. But traditional models, linear models are not following these 4 steps. Okay, now, sir, you are telling about sustainability and all, it's okay. But what is our role? Being a computer engineering student, you should apply your technologies into this. How? Sir, if you take the waste management example, there, all the bins, you make it as a smart bin. How you make a bin as a smart bin? By adding the IoT sensors. Because it will think, the bin itself will think and update you. I am get filled with the spare waste. It will update you through a message, through data. In the cloud, you will get a message saying that the particular location, particular street, particular corner, the bin was completely filled. Since you are making normal bin into smart bin by adding IoT sensor. Got it? So with that you are capturing the data. Like one bin is there, like there are many bins. In a street, how many bins are in a division, in the area, in the district, in the state, in the entire India? What is the wastage? I have to easily calculate. Okay, for that wastage, how to recycle? How much percentage we are using? How much percentage we are wasting out, throwing out? These are all the calculations. If you can use the technology, it becomes easy to optimize the data. What data here? Waste data. So waste optimization we can do properly, can plan properly, if we can apply our technology, which are in our hands. Like using AI and ML, AI algorithms, machine learning algorithms, we can easily identify because the scalability of data is very huge. Why? Because in the entire India, how many bins are there? Every bin is throwing data 24/7. The enormous amounts of data get stored into the Excel. That can be stored into database. Okay. To store it, what we need? Cloud. We are using cloud. After that, we are using services. Pay and use. From the cloud, we can use pay, subscribe, pay and use. You can subscribe. There are different topics, different services. Infrastructure as a service. Okay. Application as a service. Software as a service. Network as a service. Security as a service. Like that. Basic idea is we have to evolve with our technology to manage the resources. Okay. So here my topic is waste management for a sustainable development growth. Every individual of an India nation how to plan the activity based on sustainability as in the mind. Don't waste the resources. If you waste the resources, your future and your future generation's future will be to problem. Morning I give an example. You start GCP, everybody posing a lot of questions. For a single question, to execute a single question, the server will take some time. It fastly responding, but for that, the server utilizes how much energy? Okay, how many gallons of water is getting consumed to run the server? We don't know. Okay, just like that, we are not getting the answers from the ChatGPT. That is why don't ask silly questions to ChatGPT. If it is really useful to you, then only you can pose a question because you are wasting gallons of water which are very much needed for your next generation. Like every area, in every domain, every sector, resources are there, so there are going to be exhaustion because of your usage without a proper planning. So the second session I thought about policies. We should drive some policies by applying your technology. You all come up with some framework. If I would plan in such a way, simply I can manage the resources. I can do the optimization effectively. With that, society going to be benefited. Okay, resources are going to be maintained. Taking resources will get reduced. Making resources also get reduced. Recycling is involved. Recovery get involved. Different products we can generate. So all these things we can able to do. Okay. So for that, I just given a simple case study. Work with real waste data, perform analysis and visualization, make data-driven decisions. So some data, for next I shared to the students who are attending the morning session. I asked them by on to the Excel, I asked some questions. The task one is why hands-on learning? For that, the learning by doing. We will learn things by doing. And next one is better clarity, because project-based learning will enable you to learn things in all directions, not only three directions. That is why I insisted my students do a project in first year level, second year level, third year level, and final year level. Every semester, course and projects you have to do. For every course, you have at least one project, course and project. Okay, intentionally you should learn, you should develop a simple product and deploy. That is very much important to all of us. Okay, project-based learning will make you in all directions. You will become expert in all directions. Do a simple project for every course. Don't close the course without doing a simple project. That is the impact of the online learning, doing by learning. Okay, project learning. Then industry level. By doing, you have to go with respect to the industry. What industry is using? What tools are industry using? Don't use C, because people are not using C right now. In 10 years back, 20 years back, we may use C. Now people are depending on different languages like Python. If I don't see this, what is that? I am not doing the product in my company. What is the hell of learning C language now? If you have Python, yes, you can go and do, because Python is existing library. Okay, everything you can do just like that. Okay, so this is what industry relevant. Then coming to problem statement, urban waste overflow. Every city having their own waste. Collection of waste is very, very important. Because if I would know effectively they are collecting the waste, then I don't need to worry about that thing. Because collection is at collection time you have a problem. It gets filled in the entire flow, entire nation. All nations are filled with waste data, if it doesn't do proper collection. So for doing proper collection, what technology you can apply? Because for the vehicles, if you can apply some sensors that will easily update you what is the fee, how much data is available, how much data gets filled. All the statistics you come to know by adding the technology. At collection level, distribution level, and recycling level, and reducing level. In every stage, you have to apply your technology. Then, limited resources is another one. Need evidence-based planning. Without having a proper evidence, we cannot plan. Okay? So these are the basic fundamental problem statements we are going to be addressed in this section. So task one, data understanding. Observe waste generation across all cities. Identify cities with the highest and lowest waste generation. Comment on variation in collection efficiency. If I will have three columns like city name, number 1, 2, 3, 4, serial number, city name, and the waste collection efficiency, and rate of recycling. If I would say that, I'll show you the circle. One minute. So you can see here, there are a couple of questions to all of you. There is a city and waste generated tons by day, collection efficiency and recycling rate. These are the columns. These are the columns. Now, I want to identify the city where the collection rate is high. You can easily say because there are 5 to 6 roads. If it is 2000 million records, is it possible to say? Can you develop a program for that? That is what we expected from you people. The entire India, how many people, how many cities are there? Entire globe, how many cities are there? I want to know the statistics of the city where highest generation of waste. Okay, so this is the data set. From data set, I have a couple of questions for you. How to sort out all these things. So the task one is observe waste generation across all cities. Identify the cities with the highest and lowest waste generation. Comment on variation in collection efficiency. So you have to comment on the variation. Why the collection efficiency is less at one city? Why it is high at one city? Simple insights we can able to get it, and that is the report generation. Here data collection, analytics, then insights to take a decision. Major concerns, right? So next, data visualization. Create the following chart, bar chart. How many of you able to do the bar charts and graph charts on the Excel? Do you know how to create a bar chart and pie chart? How many of you are able to do that? Okay. Can you try now in your computer? Take the table and you have to draw the bar chart and pie chart for that. Why chart? Why we need a chart way of representation of data? Easily understand. Anybody can easily understand. The enormous data can be easily projected here, right? Okay. Then, which three cities require urgent intervention? This is the question. What is the answer for that? When we need urgent intervention? The city where waste collection is very low. Am I right? Why? If it doesn't identify it, waste can be poured like anything in the entire globe, entire earth. That makes that will impact on the nature, climate. That itself in turn will give problems to entire society, human beings. Okay. So from data set, we have to identify the cities, three cities require urgent intervention. Which city has the low recycling rate? Which city is having the low recycling rate? We have to apply a formula for that, right? In the data set. Then which city shows high waste but low collection efficiency? These are the questions to you for those rows which are high displayed. Now we have to develop a program to sort out these issues from the available data set. There are 2000 plus records, 10,000 records, more than 1 lakh records. Is Excel works for more than 1 lakh records? No. It may support up to 40,000 max or 1 lakh. Latest Excel will support up to 1 lakh, not more than that. But your algorithm, your AI algorithm, your Python program will take the data, will import the data. All the Excels can read by your program easily. There are a lot of methods, lot of packages. Using them, you can able to develop the program. You can able to create the outcome, result. First, I will show you the Excel stuff. Then I will show you the Python program for you to do the task. So now simple formula for waste not collected tons per day. First question answer. What is that? Waste generated into 100 minus collection efficiency by 100. That will give the percentage of waste collection. Recycling gap is 100 minus recycle rate. Now finally, we are going for task 5. What is that? Awareness among residents of these cities to reduce garbage generation. Then increase collection points of garbage in the city. This leads to another problem statement. Data on number of collection points, areas where garbage is highly generated, manpower available, etc. These are all the insights after looking into the output, right? So now, say this, our task 1. So this is the bar chart. Delhi is the city with the highest waste generation. Pune is the city with the lowest generation. Average waste generation across the cities is 43.4 kilotons per day. This is the outcome of the task 1 using Excel. Then this is the pie chart. Pie chart we build for what is for what? We build it for what? Rate of collection. Now, insight. By looking about these statistics, we can simply get an insight. Delhi, Mumbai, and Hyderabad are the problem cities. Pune has commendable performance. So we have to bring the awareness among the residents of these cities to reduce garbage generation, increase collection points of garbage in these cities. This is the insight, output, policy. Government, after looking about all these bar charts and pie charts, they decided these cities we have to make aware of garbage generation and collection points in these. Then, and task 4, these are the open-ended problems. Waste not collected, tons per day. From the available data, we are identifying we are answering the new questions. Because up to third slide, we are able to generate answers for the available questions. These are the new questions which are nowhere related to your data. Even we can answer. How? Because waste not collected. Some cities, 85% only, remaining percent we have to know, right? That is the waste not collected. So this we can achieve through formula. The recycling gap. 32% is the recycling rate. What is the gap now? 65%. 68%. Okay. Like that, we may answer the new questions and also the questions which are relevant to the data. Now, the same task, I will show you the Python program. So first thing is, I hope you have some idea about the Python, right? How many of you know about Python? Please raise your hand. Familiarity with Python. Only these many. Okay. So this is the Python program. This Python program we have pandas. We are going to import a package named as pandas that can be referred as a name PD. There are built-in functions in the pandas that we can use to generate output. Now I am going to run the program. This is the Visual Studio. It is a Microsoft Visual Studio. It is a tool, IDE, Integrated Development Environment, where we can develop our projects. Any project if you want to develop, it will support like anything. Okay, it is a toolkit. So it gives a lot of tools to you to write your program and execute your program and make your job easy. That is the importance of the Visual Studio. Okay, there, if I would run the program, you can able to see the output. So this is the output of my first program. It will give you the statistic summary, count, mean, standard deviation, minimum, 20%, 50%, 70%, and maximum. What is that? Tons per day, collection efficiency, recycling data rate. All I am going to display here. With using a simple function in the program, you can see the module, maximum base city, minimum base city. DF is data frame dot line of code. DF with the file name and index max, which in that column which is having the highest value will come to the max base city, which is having the lowest value will come to the min base city. After that, directly I can write a simple command, df dot head, df dot info, df dot describe. The moment when I say describe method, it will describe about the entire table which I use in the data set. All the standard mean, standard deviation, average, max value, min value, any other related to the entire data set will be displayed. This is the way of handling the data. Here, if your table may contain thousands of records, billions of records also, it may work. But Excel doesn't support for that. We read the data, we read Excel into this program. How? Read Excel is a method. Read Excel is whatever the size of the Excel it could be, we can read it easily by mentioning the file name. Read Excel method will take the file name. From there, I'll get the data. Okay? That is what the first program. Then take the second task. This is a task 2.py Python program. This I can run now. See, the Python program generates the outputs using matplotlib library. The library name is matplotlib. It will draw the charts, bar charts and pie charts. So here you can see waste generation, tons per day, and also cities. The graph between these two factors. X-axis cities, y-axis waste generation per day. If I close it, it will create another chart. Then it will generate the recycling rate by city, pie chart. Like that, we can able to get the collection efficiency rate and all. This is a task 3 program. If you would run, you will display the output. So the final output is cities with recycling rate is below 30%, cities with collection efficiency below 80%, and city waste generation tons per day for every city. What is the waste generation tons per day? Okay, high waste generation. So these are the programs we basically develop all these programs to work on data sets. Okay, so large amounts of data can be handled through Python programming. Here I used pandas, matplotlib, and open excel. Excel. These are different APIs I use. So I'm expecting you to use all these programming and develop your outcomes and work on the data set and you have to submit your proposals to research funding agencies. Okay, so this way you have to work. Because it is only the basic stuff as per my knowledge, it is the basics only. Okay, it may be something to you, but it is basic only. There are a lot of things you have to learn, you have to explore, you have to develop. Okay, so this is what you all should focus. Thank you. Thank you, Anshina.
So, good afternoon, everyone. I need you all to be a little interactive with this. So, please raise your hands. For the next scenario that I'm going to tell, all of you who relate, please raise your hands. So, you walk past any street in India, and the public bins are almost always overflowing with waste. And you always hope someone would come and clean it up for you. Have you ever got this thought in your brain? Please raise your hands. Okay, so I see a few hands raised, and cities collect these waste on a fixed schedule and not based on the actual need. So some bins are emptied when they are still half full, while the other bins keep overflowing with the waste. This produces litter, odor, and complaints, and this wastes fuel, time, and manpower. The real issue isn't the waste itself. The real issue isn't the waste itself, but it is the lack of real-time visibility and a proper and smart planning of the collection. And this is the exact problem that our project set out to solve. And our project is Smart Waste Management and Route Optimization System. It aligns with the SDG Goal 11, Sustainable Cities and Communities, and it targets 11.6.
So hello all, hope you all know me. I'm Arpit. So the audible? Yes, it is audible. So the proposed solution of our project is, as you can see, we are mainly focused on public bins which are placed on a common point in your locality, which are iron bins. You people know, right? You've been there many times. So there, basically we'll be inserting a few sensor components into the bin so that when the trash is filled into the bin and it reaches a certain level, the condition which is programmed into the sensor is triggered and the alert and the data is sent onto the dashboard so that from there the route optimization is generated using capacity-based vehicle routing problem. It is and yeah, this is our proposed solution.
So basically, our project has two things, that is software and also hardware. And I'll be explaining you how the hardware actually works. So the hardware components that we use like in electronics, any idea? Okay. So the basic things that we use for the dustbin, that is the hardware part of our system, is an ESP32, an ultrasonic sensor. So these are the only things that we used for now. So here ESP32 is mainly the microcontroller. So it's like a hardware, like the brain of the whole system. So coming to the ultrasonic sensor, it's basically used to, what do we say, measure the anything that you're using. Now here, in the dustbin, we will be placing an ultrasonic sensor inside the dustbin so that when the trash keeps collecting up and when the distance between the ultrasonic sensor and the trash is like at a minimum distance, which is called a threshold. And for this project, we use 5 centimeters as a threshold value. So once the trash keeps piling up and it reaches 5 centimeters or less than that distance, the microcontroller, that is the EXE32, will be taking that into consideration and it will show that the bin is actually filled. So that is how we will be using the ESP32 and ultrasonic sensor. And for the working of the ESP32, we're using an Arduino IDE, which is a software basically. And the coding that we will be using is C++, C++ language. Okay. And the next thing is the further advancements that we want to keep in this system will be when the system automatic, I mean, the opening and closing of the bin. So basically for that, we'll be using a servo motor and an ultrasonic sensor. And also an LCD screen, which will be displaying when the bin is full and when the bin is empty. So the next thing that ESP32 does is, so when the bin will be filled, the ESP32 notifies the dashboard saying that the bin is filled, and it also gives the details to it. And also we'll be adding a GPS module so that it gives the accurate location of where the bin is actually being kept. So the software will be told by Yashashwini. Well, here in the video, as you can see, the trash will be thrown in the dustbin and ultrasonic sensor senses the bin fill status and it's installed. So as you can see here, ultrasonic sensor senses the bin fill status until a certain threshold and it will show on the screen. See here the bin fill status is shown on the screen, the status of the bin fill. Here is the dashboard that we have created. It shows how many bins are there, how many bins are full, and how many vans are free, so that we can allocate the vans. Next, we have optimized the route. As you can see here, this red color line is the optimized route, so that we can control the manpower, fuel, etc. And green color is the antigen. As the notification sent to the dashboard, it generates the optimized route. And this is the bin status. In the dashboard, we have three pages: overview, demo, and an admin page. And this is an overview page which we can access these things: rules, how many bins are there, how many bins are full, and next is an admin page. In the admin page, we can see how many bins are full, how many vans are free. This is the coordinates of the bin, and this is the vans which are free, so that we can allocate the vans so that they'll collect the trash. And then we can click on this button, allocate optimize the routes to all the free vans. Then optimized route will be generated and allocated to the particular van. Next is the demo page. It will show the sensor data and the sensor status. This is the certain threshold, like the distance of the pin, and we can refresh the data, like if the pin is full, and it will generate route optimized. If no vans are free, it will wait for a certain time, then we can refresh again, and vans will be allocated. This is our semi-working prototype and with the demo data. Thank you guys.
Sorry guys, not yet done. Actually, there were multiple solutions which was proposed to solve this issue. So there was segregation part of the waste using many other components, which was wet and dry waste. So it was considered under failure model because you see when you segregate the waste in a garbage truck and when it goes through and if the rain is there, so the wet or the dry becomes totally wet. So we have considered it under the model because our efficiency is not yet advanced to produce such type of facilities for the garbage trucks. So it was considered under the failure model, and the proposed solution which we have worked under was to get an optimized route for the public waste which are free because there's a lot of cost constraints in this project where we cannot every household cannot afford around 2,000 rupees for a trash can. So this was particularly focused on public games which are played in your locality. So this is it. Thank you all.
So as you guys can see, this is a basic dustbin that we used, this way. So now, if you keep throwing trash into this, now if you guys can see, there's an ultrasonic sensor inside. I'll show it. But yeah, so it's basically fixed on the yeah, it's basically fixed on the upper part of the dustbin. So as you keep throwing trash into this and it reaches a certain level. So for example, let's take it, the trash has come to this level. So if you see, there's no trash right now, but yeah, the distance of from here to the end part will be measured using the ultrasonic sensor. So if there's trash up till here, the distance will be less than 5 centimeters, like because that's the threshold value that we have taken. So after it reaches, now again, this is another component that we use. It's an ESP32, okay? So this is the microcontroller that we are using. And certain connections will be made using these connecting wires. And also we'll be using a breadboard where you can keep all the components to it. So this is like the basic thing that we'll be using for every electronic project that you're doing. So yeah. And this is a cable, basic USB cable that will be connecting to the computer so that the code can communicate with the ESP32. That's the reason we are using it. Yeah, that's it for the hardware model. And now we'll be talking about a few failure models. Well, the end users are primarily municipal communities, secondary as colleges, so that it will satisfy the needs like timely alerts, less overflows, and proper scheduling. And the failure modes of this project is you can actually the causes sensor misreading. So that for that we are going to mitigate the sensor misreading by doing some testing and recalibration. And the second is connectivity loss. And for that, we are going to use the GSM fallback and data buffering. And the third is physical damage, like dogs in the street, as you know. And for that, we are going to use strong enclosures and secure bonding. That's how we are going to use for such failure mode. Yeah, thank you.